Now this next example is probably the most important bit of resolving forces that you need to get your head around, which is when we're working on an inclined plane. So if we have a body of mass 4 kilograms resting on an incline of 35 degrees, find the component of the weight of the body parallel and perpendicular to the plane. So if I just draw us an incline, and then onto that I'm going to put my body, and the weight of that body is going to act down the plane, and its weight will be 4g newtons. Now in this question they want you to find the weight of the body parallel and perpendicular to the plane. So in the first example the axis, the positive axis, was horizontal and vertical on the paper. This time that is going to be parallel and perpendicular to the plane. So that, for example, would be plus y and plus x. But it doesn't have to be that. You can set that axis to suit yourself, so long as you're then consistent when you're dealing with all the forces that are acting on the body. So more often than not, we may have it like that, but you could have it so that positive x is going down the plane and positive y is also below the incline. We'll keep it like this for this particular example. So that's parallel and perpendicular to the plane. So if you imagine that I transpose that onto the point where that force is acting, then you can see that the way that I've got that axis, this is going to have a negative x force and a negative y component as well. Now, there's two ways of going about this. Remember, we're working with a sort of right angle, creating a right angle triangle there. So the first thing you could do is, if you imagine that we've got a right angle triangle there, I know that that is 90, so I can work out what that angle there is. So that angle is going to be 180 less 90 less 35. So that angle there is 55 degrees. Once I know what that angle is, then I've got my fx and fy. So the fx is this, and the fy is this. So that means that fx is going to be negative adjacent, so it's still cos 4g cos 55 degrees, and fy is going to be negative 4g, which is the hypotenuse, and that's opposite the angle, so that's going to be sine 55 degrees. So whatever the angle is there, you take that and the 90 away from 180, and that gives you what angle that is there. So that's one way of doing it. The alternative, I just set this out again, and this is the one that certainly I tend to use, but it's just down to preference. But in all the examples that I'll be doing, this is where I'll be going. So there's my 4g weight. Now, if you imagine again, that's perpendicular to the plane, this is parallel to the plane. Now if I know that that's 55 degrees, then I've got a right angle here, so if that's 55, that angle there is 90 less 55, which is the same as that one there. So this angle inside here is 35 degrees. Now if we take our right angle to be fy and fx being this one, then all that happened is still going to be minus 4g, but this time the fx is opposite the angle, opposite hypotenuse is sine, So the fx becomes sine of 35, and the fy is now the adjacent side to the angle, so that's going to be cos of 35. So it's an either or really. Okay, and cos of 55 is the same as sine of 35. So the way that I always remembered it, rather than have to work out this extra angle, is when I'm working on an inclined plane, when I'm dealing with this particular weight, where I'm working parallel and perpendicular, that the x resolution and the y resolution swap around. So in all those questions, example in 1, the x was always cos of the angle and the y was always sine. The only exception to that is on an inclined plane, where you keep the angle the same, but then the x becomes sine and the y becomes cos. Or you keep that the x component is always cos, but then you have to work out a different angle. Okay, so it's down to preference, but usually, because they give you that, and sometimes they'll give you that as theta, or they'll give it you as a variable rather than as a fixed angle, and in that case it's definitely easier to do that, because otherwise you're going to have a 90 minus theta in your calculations. Okay, so as you practice these, I would suggest you go for that alternative method.